Let's practice using vertex form. We'll find the key points of this function and use those to graph the function. Again, the key points are the vertex, we'll start there, the y-intercept, and the x-intercepts. This function is given in vertex form, where f of x is equal to a, x minus h all squared plus k, and therefore our values for h and k are 1 and -2. We do need to remember that the vertex is the value of positive h and positive k, and we're subtracting h in the base equation. So in this case, the value for h will actually be -1, and the value for k is -2. Try this by using the values -1 and -2 that we just found, substituting it into the equation, and making sure that you get our function out of it again. All right, so that's the vertex. What about the y-intercept? Well, the y-intercept happens when x is equal to 0. In other words, when we evaluate the function at x is equal to 0, or evaluate f at 0. So we substitute in the value for 0 for the value for x. We get 0.5 is equal to 0 plus 1 all squared, or just 1 minus 2. 0.5 times 1 is 0.5. 0.5 minus 2 is -1.5. Since the question was given with a decimal value for a, I feel comfortable leaving the y-intercept as a decimal value. As a coordinate, this is the point 0, -1.5. And finally, we want to find the x-intercepts. To find the x-intercepts, well, this happens when y is equal to 0, or in function notation, where f at x is set to 0. So we evaluate 0 is equal to 0.5 times x plus 1, so all squared, minus 2 for the value of x. The first thing we will do here is convert this into standard form. It's not the only way that you can do this, but given the tools that we've looked at so far, it makes the most sense. So we have 0 is equal to 0.5, and then x plus 1 squared, of course, means that we need to take that binomial and multiply it. We have 0.5 times x squared plus 2x plus 1. If you're not sure where I get that middle 2x from, try multiplying those binomials yourself. The minus 2 on the end. So we have 0 is equal to 0.5 x squared plus 1x, which of course we're just going to write as x, and then 0.5 times 1 is 0.5. Subtracting a 2 at the end there gives me a final version, 0.5 x squared plus x minus 1.5. Now that we're in standard form, we can use the quadratic formula. From standard form, we see that a is equal to 0.5, b is equal to 1, and c is equal to -1.5. That allows us to solve for x. So x is equal to -b, or -1, plus or minus the square root of b squared, or here 1 squared, minus 4 times a, or 0.5, times c, -1.5. All of that is divided by 2 times a, or 2 times 0.5. So we find that x is equal to -1 plus or minus the square root of 1 plus 3, or the square root of 4, all divided by 2 times 0.5, or 1. That gives us an x value of -1 plus 2 divided by 1, or an x value of -1 minus 2 divided by 1, for a final answer of 1 or -3. This is the point 1, 0, or -3, 0. Alternately, if you prefer to solve the equation in the way we've written it, you don't need to first convert it to standard form and then use the quadratic formula. Here's what that looks like. Is equal to 0.5 times x plus 1 all squared. And to remove that 0.5 from the term on the right-hand side, we divide both sides by 0.5. 2 divided by 0.5 is 4, and on the right-hand side, that gives us x plus 1 squared. Now we take the square root of both sides. The square root of 4 is plus or minus 2, and the square root of x plus 1 squared is, of course, x plus 1. So x is equal to negative 1 plus or minus 2. All I've done here is subtracted 1 from both sides. So x is either equal to negative 1 plus 2, or x is equal to negative 1 minus 2. So x is equal to 1, or x is equal to negative 3, which is what we found by first converting to standard form and then using the quadratic equation. I'll summarize this and graph it on the next slide. Looking at the coordinate plane, we can start graphing those. The vertex is negative 1, negative 2. It's right here. The y-intercept is 0 and negative 1.5. The x-intercepts are 1 and 0, or negative 3 and 0. Using symmetry, we can find the point on the opposite side of the vertex that corresponds to the y-intercept, or the point negative 2, negative 1.5. Connecting those in a smooth line allows me to plot the parabola.